Okay, we're going to take a look at applying the quadratic formula, and we're going to use the graphing calculator, and we're going to use some algebra in the quadratic formula to verify an answer. So it says an object is launched directly upward at 64 feet per second from a ledge 8 feet high. When will it reach the ground again? That's actually right there supposed to be is launched. And when will it reach the ground? We really don't need the word again. I'm going to just adjust that and say when will it reach the ground, right? So we're on a ledge 8 feet high, but when will it reach down at the ground? The height at any time t is modeled by this equation. H of t equals negative 16t squared plus, we pronounce this v sub aught. And that's just the initial upward velocity. So we're going to fill that in with a number in a minute. And then that's times t, and then plus s sub aught, and that just means it's an initial height from which the object is launched. So please excuse my different fonts. That wasn't on purpose either. So let's go ahead and take a look at how to solve this, see what they want us to do. It says use a graphing calculator to estimate the time it takes the object to return to the ground or to hit the ground. So let's take a graphing calculator look at this. I already have this in the graphing calculator. Let me move it down so you can see. Here's what I've done. I've gone to the y equals window, and I've just typed in, this is what I've typed in. Let's make sure we have these numbers here. This v sub aught is the initial upward velocity, and here's what it says, 64 feet per second. So this right here is a 64. That's what's going to go in that spot. And then it says from a ledge 8 feet high. That's how high, that's the height from which it was launched, so that's my initial height. So that's going to be an 8. So when I take a look at that equation, I basically have this, y equals, or h of t, negative 16t squared, that's just like x squared, right? And then 64t plus 8. I'm going to dump that into my graphing calculator, and there it is. Alright, negative 16 x squared plus 64x plus 8. I go ahead and I've adjusted my window already, so when I look at the graph of this, here's what I see. I see that this is going to have two x-intercepts, but which one is the one that makes sense to be as to how, which one is going to be the one that will answer the question? Well, it's going to be this one right here, right? The one that looks like it's 1, 2, 3, a little more than 4 seconds for that object to strike the ground. Okay, it was launched at 8 feet off the ground, so we are going to have another x-intercept that's actually going to be negative because that's before time began, right? And so we're not going to use that answer. It wouldn't make any sense. So let's go ahead and take a look then. We think it looks like it's a little bit, I'm going to go ahead and show my estimated answer. I think that the t looks like it's about 4 point, I don't know, what do you think, 4.1 seconds? Let's take a look back at the picture. This right here is what we're looking at. I don't know, 4.2 maybe? Alright, so 4.2 maybe. So I'll change that to 4.2. 4.2 seconds, we think, for that object to hit the ground. Now, it says find the exact time for part 1 using the quadratic formula. So now we're going to dump this into the quadratic, right? And then the quadratic, and I know what my a, b, and c are, right? A is negative 16, b is 64, and c is 8. Alright, so instead of x equals, this will be t equals, right? That's always solving. This is for when the height of the object is 0. So we're really putting in a 0 for y, and that means we're looking for the x-intercepts, or in this case the t-intercepts. Okay, so when I'm trying to solve a quadratic, which is looking for the intercepts, I can use the quadratic formula, and here we go. Negative 64 plus or minus the square root of 64 squared minus 4, a is negative 16, c is 8, all over 2 times negative 16. So let's see what we get. We get negative 64 plus or minus. Now, and this time, because it's a real problem, I'm really talking about time, I really am going to get a decimal approximation. But first thing I'm going to do is go ahead and get all of this stuff. I know that can't be a negative. So if I end up with a negative underneath the radical, I've got a problem. So I know it's not going to be that. So I have 64 squared minus 4 times negative 16 times 8. I put that in my calculator and I just get this, 4608. I'm just getting 4608. Now I'm going to take the square root of that, and I'm going to get 67 point, roughly, I'm going to replace that with 67, I'm going to call it 0.9. It's 0.88, I'm going to call it 0.9. Now I'm ready to write my problem twice. I'm going to write the positive version, of this. That's a 9 over negative 32. And I also have the negative path over negative 32. That's a negative there. All right, so I have two answers, and we saw on the graphing calculator that we're going to have two answers. Let's go ahead and see what these are. Okay, so I get negative 0.12 seconds. There's one of my answers. Or I get 4.12 seconds. Now, which one of those answers is reasonable for what we're really talking about? Oops, excuse me. This is the only one, right? If it's a negative amount of time, that doesn't make any sense at all. And we thought that the estimate was around 4 seconds. It is. It's a little more than 4 seconds, and our estimate was pretty good estimate. So we found the exact time, roughly, exact is enough for us, by using the quadratic formula. So there we go. I hope that helps, and thanks for watching.